Here are Haskell tips for beginners part 2. So tip number 5 is use types. We have seen the length function, and so let me just write this down quickly again. So the length of an empty list is 0, and the length of a non-empty list is computed as 1 plus the length of the tail of the list. So it should be an x here. And what we're going to see now is that Haskell is a typed language. It also has type inference, so our program works without writing down the types, but it is really useful to know that we should write down the types. Actually, the first thing we should do when we write down a function is to write down the types. So what's the type of the length function? So the result type is an integer, and the argument is a list. So we also use square brackets not only to denote lists themselves, but also to denote the type of lists. And then we need to decide what the type of the elements is. So if you want a list of integers, we say, the length has the type of lists of integers and as arguments and returns an integer. Actually, if you look carefully at the length function, you will see that the element itself here does not appear on the right hand side. So the type of the elements doesn't really matter for the length function. And so there's a way to write down the type for the length function in such a way that we're not insisting on it must be a list of integers. So what we can do is we can use a so-called type variable. So just a small letter a here, for example. I just put an a here. So a is now a type variable, and it means that it doesn't matter what the type of the elements is in order to compute the length function. So just a little bit more about how types work. So in general, so we've seen that we can use like little letters for type variables. So let me do this. So for example, if I have a function which has 3 arguments and 1 result, double colon here, function f. So then the input types are here a, b, c. And the last one is always the result type. So for example, let's do a function with 2 arguments. Let's say I want to define a function that adds 2 integers. So if I would write this down in a programming language which looks a bit like C, then maybe, so let me write this down in a C-like language. We might write this have a function add. We define a function add, and it would return an integer. So we write this result type here, and then we would write the arguments, say int x, int y, like this. And then there would also be a body of the function saying that we return x plus y. So on the other hand, in Haskell, we could obviously use the same name for the function, but then to express what the type of this function is, we would write int, arrow int, arrow int. So the first argument, the second argument, and the result. You might ask yourself why we don't have something like where we don't write something like this, where we kind of express more clearly that add is a function that takes two integers and returns an integer. And there are many reasons why we don't usually do this in Haskell. You can do this. It's possible syntax. But let me just give you like one reason. We will see many more reasons later why what the advantage of the arrowed notation instead of the comma notation is. So let me make as an example a function which I call +2, and I already have defined the function add, so I should be able to pass one argument to add and define a new function in this way. And the type of this new function would be a function from integers to integers, right? And this does work. So if you experiment with this in the Haskell console, you can now do +2 of 3, and then the result would be 5. So to quickly summarize, one advantage of this notation here is, of this way of writing the types, is that we can pass on one argument to the function add, the first argument, and then have a legitimate function from integers to integers. Okay, so this was my first point about types. So what's the next tip? Actually, I put two more tips together now. So one has to do with correct use of parentheses and spaces, correct placement of parentheses and spaces, because this is different in Haskell than in most programming languages that you are likely to have seen before. So correct placement of spaces and parentheses. And then also another point which may look unrelated, but it can be explained with the same examples. So make use of error messages. Actually, I wanted to use a different color here. So error messages will be in red. Make use of error messages. So all these items are related to types in some way. So let me start with parentheses. And so in C, if you call the add function we have seen before, then you would write this like this. So we call add with 2 arguments. But in Haskell instead, we write this differently. So we write instead add, and then we just put the arguments one after the other, without parentheses, without commas. And so what could easily happen if you're not used to this convention is that you write something like, for example, add, and then you think maybe I should put parentheses like this. So this would give you an error message. And so let me just write down what the error message would be. So the error message here would be, so maybe you have not applied the function to enough arguments. So maybe you have not applied the function to enough arguments. So if you type add and then parentheses 2, 3 into the Haskell console, so let me write this as my prompt here, then you will get an error message which contains this question. And so it's really good to get used to reading error messages. So how do we understand this error message? Why does it say, why does it suggest that we did not apply this to enough arguments? Because if you really look carefully here, if you put the parentheses like this, then this is just one argument. Everything that is in between the parentheses counts as one argument. This is just the way parentheses work. Okay, let's try something else. So you could say, oh, but I just forget to put the comma. So really, this was just a typo. What I meant to write was instead add 2, 3, right? Like we know from our favorite imperative programming languages. But this will also give you an error message. So what will be the error messages here? So let me write this down. So this would be couldn't match expected type. Couldn't match expected type. Int with actual type. Actual type. So here at this point, actually, you should fire up your own Haskell console and run these experiments yourself. So what is this about? If you do some more Haskell programming, you will see a lot of these error messages about expected types and actual types. So first of all, let us quickly explain what these expected and actual types are. Sorry for being pedantic here, but I feel like I should write type with a little t here. So it should be. Okay, so why does it say the expected type is int? So can you understand why the expected type is int? And for this, we have to remember what the type of add was. And so let me just write this somewhere here. So we should remember what the type of add was. And the type of add was int, arrow, int, arrow, int. So add is a function that definitely expects an argument, right? And the first argument it expects is of type int. So this is why it says expected type is int, right? So we get this directly from the type signature. Okay, and why is the actual type int, comma int? So now let's look at this here. The actual type is int, arrow, int. So where does this come from? So the actual type is computed from our input here. And so Haskell is doing here a little bit of type inference. So Haskell knows that 2 is of type int, and that 3 is also of type int, right? And then from there, Haskell can compute that 2, 3 then must be of type int, int. And so we end up with 2 types that don't match. So it says couldn't match expected type with actual type. Okay, let's just quickly summarize what we talked about. So all the items have to do with types. First recommendation, always write down the types. It's part of the specification of the function and helps you debugging and writing your functions. In particular, remember that we use these arrow types. So we have seen in detail the example of adding 2 numbers, and insisted on typing this as int arrow int arrow int. And then we discussed some typical mistakes that can easily arise from this. So in particular, if we call a function with arguments, we need to remember that the syntax is not like in Python or C. And we looked at 2 of the typical error messages we can get and quickly explained the important one about expected types and actual types. Thanks for watching.